Hey guys, welcome to the show. Today we're checking out Kimi K2.5 and the team at Moonshot. They have got the general intelligence going in the AGI movement. This Kimi K2.5 is multimodal, which means it can do vision language tokens, not just text language. And it also has thinking and non-thinking all in the same model, so you can switch it up that way. And it also has something called an agent swarm. So it transitions from a single agent scaling to 1,500 tool calls. Crazy stuff going on. And they've even got a coding CLI tool that they've released as well, kind of like Claude Code, all that kind of stuff. It's all in this massive behemoth model. Now, this video, we're going to be just seeing if we can run it locally on my Mac Studio, 1 trillion parameter model, and how it compares to the version online. That's this video. And next video, we'll also be jumping in and checking out more of the features. So let's just look at some of the benchmarks here. Humanity's last exam with tool calls destroys ChatGPT, Anthropic, and Google. Destroys browse comp. Just look at that, topping all of this list. And these guys are proprietary models. These guys, you don't get access to the code or the weights. You can't see what's going on. You can't potentially run it locally. I knew you need some serious systems. I've only got a Mac Studio and a MacBook Pro. We're going to be running it on the Mac Studio itself, just one. And we're going to be seeing the largest model we can go on the MacBook Pro and the Mac Studio combined distributed. And yeah, it's still open. I mean, if I had 2 Mac Studios, I can properly get it running, but fortunately I don't. But I've got some quantization techniques that hopefully will get a good job. But yeah, look at these benchmarks, amazing. And even the image ones, not the best, not the best, just by a couple of points, but it is still up there. So let's jump into Inferencer. I'll show you it loading off the back. So I'll hit that loading button over there. If we look at the model, this one that I'm going to be running is 470 gigabytes. Now I am running the text only version of Kimi K2.5. I don't have vision language encoding in yet. It'll be coming very, very soon. Now that everyone's kind of doing it, I kind of have to do it, but we're going to run that. And interestingly enough, it's still the same number of gigabytes as the thinking version, which didn't have vision. So they haven't dumbed it down. It's still a very intelligent model. It is loading away right now. I'm actually hammering my Mac Studio at the moment. I'm uploading this quant over to Hugging Face as well. And actually something I want to share with you guys. If you check it out right here, I'm officially a pro member of Hugging Face. They said you can't upload anymore. You're using too much of our space. You're gonna have to stop paying us. So I said, okay, it's some money. Here you go. And the version that I've uploaded over here is the 3.6-bit quant, and 3.6-bit is the smallest version I can quantize it to that still has coherence. So if we look at this table here that I've prepared, the base model for Perplexity, you usually get around 1.2. So that's the highest it will be. That's the confidence level of it picking the tokens. So you're not going to get 1.0 unless it was 100% confident that it was going to pick all the tokens as it is. So you got 1.2 in Perplexity. Q6, the version that I love, is 121, and you get 96.95 token accuracy with a misdiversion of only 12%. So when it isn't sure which token it's going to pick, it's only 12% off. So that's amazing. Now the version I've gone for is the 3.6, which is a perplexity of 1.59. It's lower than 121, so we're not going to get the smartest answers out there. Token accuracy is 83%, so again, it's not close. And misdivergence is now 40%, so it's a lot wider. But the next step down is 3.5 quant, and that perplexity is just off the scale, ridiculous. So that's what I've got right now. We're going to be doing some more intelligent quantizations in the future, but that's the version I'm going to be running. And also see the largest version I can also run when I distribute it, compute it. And let's just jump in and see how it goes. So we've got it loaded in. I just want to say hello to see if it is comprehending. And look at that. The user said hello twice. How can I help? So it's thinking by default on the local version. You probably, let's just see if it works. I'm going to add in control the response, and I'm going to add in a think tag just like that to see if that works. So let's continue that message. And look at that. So you can disable thinking really easily by just adding in that think tag over there. So that if you want fast answers, it will get it going like that. So let's just start off the show and just see if you can still comprehend some riddles, because that's how I usually like to test these models out. So I've got thinking disabled right now. In the next version, I'm going to have the thinking button back. This is version 1.9.4. Just submit to the App Store, so you should be getting it very, very soon. So with thinking disabled, it knows that it's the boy's father. Boom, that is a very good response. When I give this question to ChatGPT, it comes up with the wrong answer. Now with thinking enabled, are we going to break it? And we can see back with this quant, 27 tokens a second. So even this is a trillion parameters, it is very, very fast on this. It's thinking through the riddle. I'm going to jump in now and I'm going to go into Kimi's official website. I'm going to ask it the same prompt. I'm going to give it the instant version. And look at this. The instant version on the online, I'm hoping it was unquantized. It actually picked out the mother. So 1 for local. Let's just see if this guy, the thinking, it's really, really thinking it through. It hasn't got the answer yet. Answer is the boy's mother. But it's still trying to figure it out. It's got over 1,400 tokens. So we're thinking on is really thinking through the problem. Now I'm going to give the online version, the full version, another go. And I'm going to enable thinking. And let's just see if you can figure out when it's got that thought process going. So the answer is the boy's father. I saw it, but it's still unsure. Look at that. It's printing just as long as the local one. So, the surgeon is the boy's father. So we're thinking enabled, the online version, smashed it. Now, one thing I do run and with thinking enabled on the local version, it's the 3.6 version. And again, really comprehensive. We've got some good results there. I'm going to just check out the token accuracy and it's 100% sure that it is the father. Biological is going to go through some weird rabbit holes. Now, one thing I do run when I run it locally, I like it running with a low temperature. So my temperature is 0.1, which means it sticks very, very close to the source material. When you have a high temperature, you could potentially deviate. You know, when I was telling about the percentages where it deviates because of the quantization, that temperature can also make it deviate by quite a lot. So I like keeping it close to the truth. I think the guys at Moonshot, they don't know what their audience is. So by default, when you're talking to a chat, you probably want, conversational kind of computing. You don't want to have the appearance of robotic answers. So they probably have their temperature a bit higher just to make it a bit more conversational. So that's why it probably got it wrong with the instruct version. But that is a pass. I can't believe the local version got 2 out of 2 correct. That is good. I'm going to give it the runaway trolley and I'm going to disable thinking. Boom, 28 tokens a second. The 5 already did it. It knows straight away. Very, very smart. Even though we've lobotomized this model, very, very smart over here. I'm going to enable thinking again to see if it can still get the right answer. And that is amazing. That is really good. It's going to go through the thought process. We're going to check out the online version. I'm going to give it the instruct version again, instant. Clever twist, traditional. It's a bit slow. I think the servers must be getting hammered at this moment in time because they just released it, a new model. But I think it has comprehended that they knows it's already dead. So I think it's also, no, you should not pull the lever. And that is good because last time we ran Kimi K2 thinking, it actually said it would pull the lever. But that was a thinking enabled. So let's just see if thinking enabled will break it. It's thinking through the answer. And in the meantime, let's jump back into Influencer, run it locally. It's still going through 1,200 tokens. It is finishes thought process. No, you should not pull the lever. There you go. Pulling the lever kills one person. The other guys, they are beyond help. So locally, again, answered it correctly. Both of them. That is good. I love this model, the potential of it. Now the online version with thinking enabled, you should not pull the lever. So they have figured it out. Boom, shakalaka, that is good. I'm going to switch it up. Now I'm going to give it a coding problem. And this is a regex challenge. And for models, they struggle on regex. There's only like less than a handful of models have actually got this answer right. And I think 90% of them needed to have thinking enabled to figure it out. This is the 3.6 version of Kimi K2.5. And we have disabled thinking. I think it might have already got the answer. So the riddle was here is KM0 and we're looking for a 1. So KM or 0 is not a 1. It has got it already. Look at that. \W or an underscore. So it's actually answered this. This is correct. This answer would work. I mean, it gives a lot more, it's more open than if we constricted it to having an underscore. So it's got an underscore, a number, or a letter. So that is the right answer to that without even thinking. And in 600 tokens. Now, the next best model up there took 6,000 tokens plus to get to this answer. So thinking disabled, I'm going to be adding a button here to enable disabled thinking to make it a lot easier. Let me enable thinking. And let's try it again. Most models need thinking to get it right. So let's just see comparison. Is it going to think for less than 6,000 tokens or is it going to be just like the other models for these complicated questions? Online version, we're going to jump in. I'm going to keep thinking disabled as well. So we're using the instant version online. Look at that. I think the Mac Studio version, look, it's smashing it out, 25 tokens a second. And the online version, look, it's struggling. It's struggling. They are getting hammered, these Moonshot people. So congratulations to them. Their servers are getting overloaded. So they're going to be getting more users, hopefully, and really bringing us. And we've got to be thankful to them because they're actually releasing this as an open weight model. So you can actually use this, and maybe what might not run on your computer today, but next year or the year after, you're going to have very, very capable computers. So the stuff's only going to get better. The answer, it's coming for it. Oh no. Oh no. Oh no, 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 no. KM0. It kept KM0. Oh, wait. So he's given us two answers. Actually, he's given us three answers. The first answer he gave us is wrong. That will fail. But it might pass. It's got a plus there, so it might pass. But it still kept the KM0 confusingly. Then it's optimized it. It's got AZ09, so that's good. And it's optimized it again. It's got AZ capitals and lowercase. So that is actually the right answer. They've done it. So even though this is the instant version, it kind of did have a thought process. It did kind of figure it out. I'm going to run in and see how the thinking version compares because we got to get that going. And locally, we got 2,000 tokens going. It has now, look at this. It's added in some extra cases that I didn't even ask for. So it knows about quantizations and how it's like to be represented on Hugging Face. So it's actually added in IQ. That wasn't even in there. KMSL, XL. So it's giving me a really advanced answer. That's good. And you can see that it is optimizing the part that was breaking. So let's put them side by side. The online version has done it. So they've definitely put more server units on the thinking version because that's probably where it needs it. And it's given us the answers. And again, it's the right answer. The local version we want to see now is the local version going to do it in under 6,000 tokens because that is the kind of levels that the other models complete it in. And boom, 3,200 tokens, 22 tokens a second. Memory wise for this one is 446 gibs. So I've got a lot of room for context window if I use this quantization. And I know 3.6 doesn't sound like a comprehensive quant, but look at it right there. It's got the right answer. We're thinking enabled and disabled, and less than a handful number of models can actually get this answer correctly. So that is a good one. I'm going to jump in now and I'm going to see how it produces actual example demos. So I like to do the 3D solar system example. So maybe I'll just jump in and do that, except I'm going to enable batching. So I've got batching now enabled, and batching allows me to run multiple prompts at the same time. It'll run a little bit slower, but the total throughput will be faster. So I'm going to smash out a couple of examples to see how it does. So MS Word clone single file HTML with thinking disabled. And then I'll also have it with thinking enabled just to see how much of a difference thinking does. So we got two inferences running at the same time. It's around 16 bit tokens a second. So that's 32 tokens a second. We're getting a lot more performance. This one, I'm going to do the cleverer one, 3D solar system. And for this one, I'll keep thinking enabled. And I'll say Flappy Birds 3D. So we've got 4 inferences going at the same time. I'm not sure I'm able to do this with the memory constraints. Maybe 4 is a bit too much. With batching, you're not just managing one context window, you're managing all the contexts of 4 inferences at the same time. So if there are a few thousand tokens each, we're going to be in trouble. So we've shot up now. Our total computer is using 489 gigabytes. Inferencer itself for this model is 470 gigabytes. What's good about it is I can see the 489 figure is stable. So they're about 9.4 tokens each. So it's just under 40 tokens a second. We're smashing this out. We're at 499.5 total usage, 480. So there is a pathway to potentially get this done. So I got another 10 gigabytes of potential context window to get it done on this machine, but we'll see what it does. I'm excited to find out. We're at 8.5 tokens a second each. Let's just see, and let's compare it with the online version. Flappy Birds 3D Solar. So we got our own little batching competition here. Look at it. It's coming to a crawl. It's coming to a crawl, the online version. Their servers must be getting hammered. So the Mac Studio version is doing really, really well. Pretty happy with that. 8 tokens a second each, and 1,000 tokens with the other demonstrations. So we might just be able to get this done. We still got another 12 gigabytes of potential in there. All right, unfortunately, running 4 inferences at the same time with batching was a bit too much for my system. Kind of overloaded it, had to restart it. But we've got it back. I'm doing one at a time this time. I'm still uploading to Hugging Face. I'm still using up memory. And I've still got like Xcode on, all that stuff that uses gigabytes. But that being said, with just one inference going, we've got 5,000 tokens here, 18.2 tokens a second still, and we're only using 475 gigabytes in total memory used. My system is 499. So, you know, if I shut down some of my extra applications, I'd get a much bigger context window. And it's actually done, so that's good. So Flappy Bird thinking is thinking it through. So we got 4,700 tokens with MS Word non-thinking. We got 5,400 tokens with MS Word thinking. And we got only 2,600 tokens with the 3D solar system. So that's disappointing because if we look at the results here with MS Word, I don't know how much tokens that is. There isn't an indication, but I do recall that the 3D solar system was massive. Just look at that. Look how much code it has made. So let's jump in and just see what we've got so far. So this is the online versions of the 3D solar system. Very, very gorgeously impressive. You can actually click on the planet. It's got an asteroid belt. It looks gorgeous. You can speed up the speed. There is one thing missing though, and that is lighting. I don't know what's going on. Even with other models, it's also had issues with the lighting, but very, very beautiful result over here. The local version with only 2,600 tokens. I'm not hoping for this, but boom, okay, we do have something, and look at it, it's lit correctly. So even though we produce a lot less tokens, it still ran. There was no runtime errors, and this is a really low quant, 3.6. That's amazing. Can we click? We can't click, so it's not got the extra oomph factor, but I'm sure we can prompt it to a better workload because it still has the intelligence in there. So there's still some work to be done. So it is good because it runs, and it is good because it does have lighting. Maybe it doesn't look as impressive here. It doesn't have the asteroid belt and the clickety click that you can do. Look at that amazing motion. That kind of getting lost there. Let's just refresh it. But that being said, it does run. Let's jump into Word. So this is the online version of Word. Let's just run that. I don't see any runtime errors, but for some reason, it's not actually doing anything. So we got a potential for a comeback for the local version of Word, and boom, is it right? We do have text. We can use it. We can use it. I made a bullet point. Can I change the font? I changed the font. I changed the font again. Can I make it bigger? That is gorgeous. That is really, really good. It worked. And it's, can I change the color? I changed the color. So this is a very, very feature-rich version of Word. I can even do find and replace. Is that right? I don't know. Don't know if it's working, but it's definitely working better. Look at that. I'm rotating the page. A4 letter. Don't know what it's doing. It's doing something. So yeah, that unfortunately, that is a very, very unfortunate thing. Now, the thinking version of the online version, that looks more like it. I don't know if it's actually better than the non-thinking version of Word. I do like the contrast between the blue and the white there. This one maybe is a bit too white, but it looks gorgeous. Look, it's got shadow around the page. Can we change the font? We can change the font. Can we make it bigger? We can make it bigger. Now, some models actually fail on these little tasks. Like you get a blank bit where the font is. So it's comprehended a great result there. I'm moving it left and right. I've added bullet points. So that is gorgeous. It's got a theme page. Look at that. I click theme and it switches it from black to white. So that's gorgeous. Insert image URL. So this is a very, very good version of Word. The local version, again, looks very, very similar. If we take out the theme, looks very, I think the non-thinking version might be better looking. I do like the contrast between there. So it doesn't have that contrast. We've got new, we've got save. Can we change the font? We can change the font. Can we make it bigger? Can make it bigger. We can also add a little bit of a, I don't know what that was doing, but we definitely can add in some stuff, add in a picture. Yeah, so it's still running. No runtime errors. The functions seem to work. This, probably the thinking version online is better when it comes to the non-thinking version, the local one at even 3.6 quant. That's how intelligent this model is at 1 trillion parameters. It beat the online version because the online version didn't even run. So that could be even a minus score there. Now, finally, we're going to jump into my favorite one, and this is Flappy Birds. Let's run it over here. This is the online version of made with Kimi.com. And again, it's a very, very challenging one. It works, it runs. It's easier than some of the versions I've played of Flappy Birds. It gets a minus point because the maze is just straight, but there is still a challenge. Locally, We're at 3.6. We only took 3,974 tokens, 22 tokens a second, and we got, oh, that is a fun. I don't know how to play it. Oh, I'm not good at this game. Okay, we got, this game's hard. This game is hard. All right, so we got a different perspective. It gets a point because look at the maze. It's changed up the maze. That bird doesn't look as good as, well, that doesn't even look like a bird. That's more like Pac-Man with a nose. And this one looks like an airplane gone wrong. I do love the perspective of this. There's definite potential to be done with the thinking version of Flappy Birds. But that is an example, a showcase of Kimi K2 thinking right now, running locally and online. I think we're going to wrap it up for today. Stay tuned. Maybe tomorrow we're going to jump in. We're going to check out tool calling. We're going to be running it distributed compute to see an even larger quant. How good can this model get? It's going to be amazing. We're going to check out some of the other features of the online version, including vision. How does that improve the game? And I'm going to have to integrate vision into the local version to just see how well it runs. What do you guys think? Is AGI coming to life? I think they're adding all the multimodality and they're keeping it local so lots of smart people can work on it. Researchers, like for example here, when you run locally, look at that. We can do a token inspection. We can jump in, use things like token entropy. So this is where the model was confused properly. It could have been thinking about saying carefully or properly. So you can really get into the weeds, get into the mind of the model when you do have access to it. So it's a great thing that they're doing, this Moonshot, making it available to run locally for researchers to make AGI safe when it does come out, like giving it to the masses, not just to the singles. So what do you guys think? Check it out. And it's uploading on Hugging Face right now. I'm officially a pro subscriber to Hugging Face because they wouldn't let me upload anymore, uploaded too much. So if you appreciate these tests and you want to find out more, leave a comment and let me know what kind of tests we'll do for the next run. Hope you guys found this video useful and enjoyed the show. All right, Kimi K2, make me Kimi K3.